Hello guys, welcome on Tesla Adventures. In this video we are going to discuss a very important and very easy concept of buoyancy. So you can see that there is a container which contains three different liquids of density rho 1, rho 2 and rho 3, and the height, there is a cylinder which is partially floating on the interfaces of these three liquids. This cylinder is in equilibrium in such a way such that h by 3 of its total length, 1/3 of its total length is inside the first liquid, h by 2 is inside the second liquid, and the remaining length is this one, which is h by 6, is inside the third liquid. And we have to find out the value of sigma in terms of rho 1, rho 2 and rho 3. Now first of all, let us discuss a fact that if we say that net force on cylinder due to liquid 2 will be 0. Obviously it would be 0 because liquid 2 will be applying these forces in opposite directions, and these forces will be equal also. So they will cancel out each other. But when we will establish the equilibrium, we would be writing buoyancy 1 plus buoyancy 2 plus buoyancy 3 of all these three liquids acting on the block, and in the downward direction it would be mg. Now obviously I know that there is a question which is arising in the mind of you all, that why you are taking the buoyancy of the liquid 2, as you have already written that the force acting on the cylinder by the liquid 2 is 0. But let us discuss this concept. I know that I have written that force acting on the cylinder is 0. So if there is a question in the test that the net force acting on the cylinder by the liquid 2 will be, so we would choose the correct answer as 0 only. But why I am taking this buoyancy is the fact that due to the height of this liquid column of liquid 2, this is some non-zero height of liquid column, it would be creating some additional pressure at the bottom. It would also applying the pressure at the bottom, and that pressure is contributing in the buoyancy 2. That additional pressure is buoyancy 2. This is that additional pressure into area is buoyancy 2. We can also prove this fact that buoyancy 2 will be volume of solid immersed in liquid 2. So in liquid 2 the volume of solid is h by 2 rho 2 into area is A and G, and therefore we can say that at the bottom the delta pressure, additional pressure due to liquid 2, will be height of liquid 2 is h by 2, density is rho 2 into G, and area is A. So this is extra force due to the second liquid. So this force is exactly equal to the buoyancy. So actually I am writing it as buoyancy, but this is the force due to the pressure applied by this liquid at the bottom. So this is numerically equal to the buoyancy only. So we can use it as buoyancy. Therefore B1 plus B2 plus B3 will be balancing mg, and B1 will be rho 1 into h by 3 Ag, B2 will be h by 2 into rho 2 Ag, and B3 will be h by 6 into rho 3 Ag, and it would be equal to sigma Ah into G. So cancelling this AHG, sigma will be rho 1 by 3 plus rho 2 by 2 plus rho 3 by 6. This will be the value of sigma. Now we move on the next on the next video. We'll be discussing the concept illustration problems based on the buoyancy. Thank you.